For those of you who have been coming to this conference from the very early days, you'll remember the excitement around MPLS and VPNs. This time around, it's the same level. I would argue that it's even more exciting this time because of the change that we are talking about bringing to networking, because of the complete rethink that we as an industry are looking at in terms of building networks, in terms of managing networks, in terms of operating these networks. This is a huge change. We're talking about making networks consumable by the applications. That's the innovation that we are talking about. And it's making networks as consumable as compute has become. So truly it is, in some ways, this innovation and the networking and the dramatic change that you will see in the networking is starting in the data centers, fueled by really the cloud computing and the requirements of cloud computing. And what are those? That you need very rapid deployment of applications onto the network every time, anytime, any cloud. Those are the requirements. For that, the compute and the network need to be in sync. And unfortunately, while we have done a lot of good work for the last decade in MPLS, in multi-tenancy, in VPNs, in protocols, what we haven't made the networks do is become consumable for the applications, the automation that's required. And so that's what we need to do to really deliver on the promise of cloud computing. We need to be able to make the networks and the compute in sync so that applications can really be deployed very rapidly onto the network, that the network becomes as agile, as responsive as the compute has become. So you may ask, what technology or framework is going to help us do that? Software-defined networks. SDN truly is the technology and framework that's going to help us bring network in sync with compute. Now, how do we do that? And where are we in this journey with regards to SDN? That's what I'm going to talk about. Because we embarked on this journey with SDN, and the promise of SDN of making this network as consumable is fantastic, but we've seen some early use cases, and with the hype in the market, it's caused some confusion. And what I want to do today is talk about what SDN is, what it should be, what our view at Nuage Networks of SDN and where it should be, and how SDN transforms the networks today from the data centers all the way to the branches, to the VPNs, and also in the campus networks. So let's get started. So the market sentiment and any debate, if there ever was, on SDN is completely settled. SDN is absolutely going to bring dramatic change to how we build, operated, and deployed networks. Now, how that happens and the journey that we started back in 2011, thanks to ONF, was really where everyone was questioning what SDN actually is. And in 3 years, we've gone from what it is to understanding what SDN is, but now the question being asked by the customers that we talk to is how? Show me how. So we've gone from what to how, but there's still a fair amount of confusion. And with tremendous market projections in terms of what this SDN market sizing is going to be in tens of billions, there's obviously a lot of hype. Of course, new entrants, startups in this area like us, we love this. We love entropy. We love the change. And legacy vendors are and have been rudely awakened by SDN and what it might do. So let me take you through what our view is of SDN and then talk about some of the use cases, early use cases. Let's step back. So why do we need SDN? Why we need SDN is because of the big C, or rather 4 big C's. The networks today are standing in the way. The networks are not as agile, they're not as responsive, they're not as automated, and they're not abstracted for applications to be deployed rapidly. And as a result, the networks are complex, they're custom, they're highly customized for the applications, and they're costly to maintain and operate because the automation and the integration work is done on a release-by-release basis. It becomes extremely difficult as a result to, in fact, change the network infrastructure because the inertia of that change is so huge. As Guru pointed out early this morning, it takes about close to 18 months for anything to get deployed in the network because of the customizations that are required. So as a result, what happens? It becomes a closed environment. This is the reason, these are the main motivations why we need SDN. So the truth about SDN. What is SDN? To us, it is a way for applications to consume the network resources very rapidly. But what it is not is an answer to every networking question. And that's what it is right now. That's the, again, because of the market hype and some of the early use cases which are legitimate use cases, but they're causing some amount of confusion. And so it's really time to lift the cover, if you will, and lift the cloud over SDN. Let me start by giving you a definition of SDN. To us, SDN is about bridging the gap between applications and network to enable very rapid consumption of network services by applications by giving the applications control and visibility. It's about abstraction of network capabilities, and it's about automation of network provisioning. It's about separating what applications need from how the network actually deploys and provisions that behavior that the application needs. So to us, the key objectives of SDN are about abstraction, about automation, about control, and about visibility. Very, very fundamental, but key for the entire SDN and entire network to dramatically change from where it is today to where we need it to be. Let's start by looking at some of the early use cases. So the first use case, circa 2011, was about separation of control and data plane. And this was all about OpenFlow and how OpenFlow enabled the separation of control and data plane. Well, the fact is, we've done this for a number of years. If you look at any router, you got a control plane, and you got a back plane, and you got the forwarding elements. The control plane is where the control protocols run. Once the intelligence is gathered on the connectivity and where it should be, that intelligence is then programmed into the forwarding elements, but the connectivity between the control and the forwarding elements is actually the back plane. Now what we talked about with OpenFlow is we separate the control and we put the control in the cloud. Great. But at the end of the day, it's really a southbound API to program the forwarding behaviors in the network elements. Does it give some level of control? Absolutely. Is it a good first step? Absolutely, it's a great first step because it allows for any generic network elements to be programmed from a controller by separating and having this separation of control and forwarding planes. So it does give us the control, but it's the first step. So the next step is about talking about the next generation EMS systems that are in the market and asking ourselves, is this SDN? Well, the next generation EMS systems basically are talking about replacing CLI and script-driven element management systems This is, by the way, one area where really the industry hasn't progressed that much. And replacing that with a platform that's a centralized network management system. So rather than a box-by-box element management system, where you're configuring through CLI, through script, through whatever SNMP, whatever the southbound API might be, OpenFlow, you're talking about a network management system that allows you to really program service at service layer, but using any southbound protocol. It could be OpenFlow, it could be XML, it could be SNMP, it could be CLI, it could be JSON RPC. It doesn't really matter. What it does is it gives you the ability to have the end-to-end service level view of the entire network and be able to create networks through this new next-gen EMS system. The question, though, is this, as I said, really giving us and delivering on the promise of SDN? And the reason I pose this question is because, yes, it gives us control. Yes, it gives us visibility end-to-end. And arguably, these solutions have been shipping for a long time from some of the vendors, including Alcatel-Lucent. However, it doesn't do anything to change the present mode of operation, because the network is really still the same network. The elements in the network are the same exact elements in the network. It hasn't done anything to give us the agility. It hasn't done anything to give us the automation. And it hasn't done anything in terms of bringing up new services, bringing up new sites quickly. In other words, for the network that we are talking about, where we want to go, is a network that adapts to the requirements of the application instantly, just like what happens in the mobile networks. The network adapts to the requirements of the mobile phone. That's what we are talking about. This doesn't go that far to delivering on that promise of SDN, on taking us to that network where we want to go. This is another use case that's talked about quite a bit. So is SDN then traffic engineering, where the objective is to run the networks really hotter, make sure that you're really optimizing and using the network capability. So we have a use case where we have offline PCE, where requirements of the network, requirements of the applications, requirements of time of day, all these requirements are fed into the network, into this database. It crunches that, taking into account all this, and comes up with the optimal path. Those paths are then programmed using OpenFlow. Remember, it doesn't matter what the southbound protocol is, but in this case, in the early use cases, we have seen OpenFlow being used to program those forwarding entries. Has this been done before? Absolutely. Until now, we've been doing this through RSVPT, through inline protocols, allowing operators to give certain parameters to the PEs who signal the EROs, and based on that, the path was created, traffic engineered through the network. Or you could do it by hop. And honestly, for those of you who have been in the industry for a while, the offline traffic engineering has actually was being done by MCI in late 90s before RSVPTE came along. Yes, it wasn't as enhanced, but it did what they wanted it to do. It crunched in the background offline, and then they used SNMP to program the paths in the network, or the LSPs in the network. So the question, again, is, does this use case deliver on the promise? It definitely gives us the control. It definitely gives us the visibility. But what about the agility? What about the automation that we are talking about creating new services? This is about optimizing the network infrastructure, the underlay, if you will. It's not about deploying new services rapidly. It's not about allowing applications to be deployed rapidly onto the network. So at Nuage Networks, we believe that SDN is truly and has to be a complete rethink, a new approach to networking. And as I said, it starts in the data center because that's where the requirement is most pronounced. And that's where the network inside the data center has really fallen behind, even in terms of the multi-tenancy. And some of the protocols that are run on those decades-old equipment, and we have progressed a lot in terms of protocols and multi-tenancy in the wide area, haven't quite done it in the data center because of cloud computing and because of the need to deliver on the promise of cloud computing. That's where things are starting first, but absolutely is going to progress beyond data center into the VPNs, into the branches, into the campus networks. So the rethink is about not thinking of the network as we have been doing for the last decades as a product, but really thinking about application delivery as being the product. That's what we need to look at. Let's look at it from the perspective of the applications. What does the application need? And how does the network then adapt itself to delivering what that application needs automatically, on the fly, dynamically, every time? And that's what we're talking about. This is what SDN should be, which is it needs to change according to the requirements of the application and the user. So the two key fundamental areas where we believe it needs and things need to change are starting with a fundamental shift in abstraction. Abstraction as in how applications interact with the network. Today, for any applications to be deployed on the network, the applications have to be engineered with the understanding of what the network capability is, what the diameter of the network is, what VLANs, what protocols are being used, whether there's resiliency, and based on all that, all the application delivery and the deployment of the application is based all around that, and what that means is it gets lost in translation. Rather, we need to move to an IT-friendly definition where application behaviors are specified at an abstract level without the applications worrying about how those behaviors are implemented by the network. The applications absolutely shouldn't be worrying about anything in terms of what the network is and should try to engineer around the capabilities of the network. And that's what we mean by IT-friendly definition. So to be more specific, it's about providing this level of abstraction where any user anywhere in the hierarchy, whether it's the end user, whether it's the department, whether it's the IT admin, whether it's the service provider, is able to refer to abstract network behaviors in terms of domains and in terms of application containers, and not have to worry about the IP addressing, the subnetting, the VLANs assignment. It's about, I want my web servers, and I want them in zone 1 of domain 1, and I want the web servers and my database servers to only talk with HTTP as being the protocol. I'm not worrying about actually IP address assignment for each of my web servers and my database servers. I'm not worrying about the ACLs that need to be applied at every entry of those servers so that only HTTP traffic is allowed. All I'm saying is I want the web tier to be in zone 1. I want my business logic tier in zone 2. My database tier back in the enterprise is in zone 3. I want only HTTP traffic allowed between these zones. I define this. I push a button, and things could happen automatically. That's the power of abstraction I'm talking about. The second fundamental shift, we believe, is in terms of automation. Automation as in moving from device by device by device management and provisioning of the network. Because even the next-gen EMS, it is going and programming every single device. Yes, it's allowing one common layer and it may be using several southbound protocols, but it's still device by device by device programming and device by device by device provisioning. This is broken. This is not the way it should be. It should be completely automated. Automated as in how we have done the mobile phones, how the mobile phones work. And to illustrate that, let me show you with an example of what we've done in the data centers, for example, where you got the compute and storage management, and you got the policy engine. So what happens? When a virtual machine is instantiated, as soon as the virtual machine is instantiated, think of it as a mobile phone being turned on. You arrived at the airport, you switched on a mobile phone. The first cell tower captures the unique ID of the mobile device. It sends that unique ID to the HLR, and you get authenticated, authorized. Your SLA is then matched, that you're allowed all-you-can-eat data plan, you have roaming capability. That information is conveyed to the cell tower, and the network just configures itself, and you're able to automatically do tweeting, IMing, emailing, and talk on the phone instantly. It doesn't matter where in the world you travel. This happens all the time. If you've done that for millions of mobile devices, why can't we do it for millions of endpoints, network endpoints? We're starting with the virtual machines in the data center, but it could be any network endpoint. Why can't we have that kind of mechanism to really provide that level of automation? So that's what we believe is what is required in terms of the actual tool set. As I said, massively distributed network endpoints. Massively distributed network endpoints doesn't matter whether it's in one data center, multiple data centers, or in the branch, over the VPN, in the campus network. As these endpoints come up, they're connected to the network. The SDN controller offers federation. It offers federation, and there was a question earlier. The federation, we believe we need to leverage the protocols in use. So MPBGP is a perfect protocol for using and providing that federation and making the networks boundaryless, as we have done internet. It scales. It's multi-domain. We know how to do it, and it's been operational for years. And then finally, the policy and analytics layer, critical, because enterprises and the CIOs that we talk to, they love the agility. They love the promise of cloud computing. But what they're nervous about is losing control, losing visibility. Having a policy layer that allows you to have full control and visibility so that if there is a security threat, instantly you can shut down a protocol network-wide, instantly. And you have full analytics available for all your network end devices. So I'll start to summarize here. The key elements from our perspective are not control and visibility. They should be implicit. The explicit requirement is really abstraction and automation. And having abstraction and automation at the level that we have described and having control and visibility gives you the full capability to really take the networks and make them fully automated. I would be remiss if I didn't talk about NFV. So what is NFV? NFV, and you've already seen multiple presentations. To put it simply, NFV is about taking the conventional infrastructure where you have people managing every single capability that's offered in the network, whether it's IMS, whether it's CDNs, whether it's IPTV, whether it's RNC, and moving that to a software-defined environment, virtualizing those functions. Virtualizing those functions and taking advantage of the cloud to really scale out and have a scale-out architecture. Yes? So I'm getting the hook, so I'm going to quickly go through this slide. I call that cloudifying the network or networking the cloud, where we are doing the SDN platform that underpins the IDEA applications and the workloads. As we move to virtual network functions, that's what we are calling cloudifying the network. You have the NFV platform that enables that, and then SDN layer goes across. So NFV is really a use case for SDN in some ways, because SDN underpins any virtualized network infrastructure. And it's all about bridging the gap between applications and the networks. It doesn't matter what application it is. SDN will allow that in every time fully automated manner. So in summary, SDN is a framework that offers abstraction, automation, control, and visibility. It truly enables the realization of NFV by connecting all apps to the network. And by the way, it could be NFV or it could be any IT apps. Bottom line, we are about using SDN to make the network consumable at the speed of apps. Thank you.
Thank you, Sunil. If you have burning questions, I allow one. Otherwise, leave it to the panel. Okay, the gentleman from Telstra.